So hello everyone and I welcome you all to the Rankplus. In today's class, basically we are going to continue our previous lecture which was on rotational motion. Unfortunately, that lecture was being stopped due to the electricity issue. So in this video, I will continue and will ensure that we will complete each and every parts. So I have divided your JEE main syllabus for the rotational into 9 equal parts, and the ninth part is very special because it's the spatial technique which I use to solve the questions related to the rotational motion. So I have divided this complete whole lecture into 9 parts. The first part was for the basic concept of rotational motion. We have already completed this in the part 1. The second part is of moment of the force and the torque. This is also completed in the first part, and the third part is related to the angular momentum, conservation of angular momentum and its application. This is pending. Okay, from third on it's totally pending. So we were basically doing the equilibrium part in the previous video, which was part 1, and you do not need to watch that video to watch this lecture. You can watch this lecture independently. There is no dependency at all. There is no prerequisite for this lecture to attend. Okay, so do not have any doubt regarding that. If you have missed the previous lecture, then you won't be able to see this. You can watch this, and I'll be explaining you each and every topic with a very like, I'll be taking it from the very basic things to the advanced level, which I have to cover for your JEE entrance exam, right? And let me start the chat here as well so that I would not miss any of your chat. Please light up the chat, show me your energies here, and do share this session with your friends, guys. So hello, Rock with N Naveen. I need money for school fees. Where are you from, Naveen? Naveen, if you are my regular student, then I will definitely help you, because I have done this before as well. When I was in the previous organization, there are so many students who wanted some kind of help, so I have provided the amount. So I'll talk to you later on after the class, because in in this class I won't be able to do any transactions. You are from Tamil Nadu. So you shared the notes only for the chapter gravitation and motions in a straight line. So we are feeling difficult to revise the concepts without notes. Warrior, I will share all the lectures notes after this class. Okay. If I haven't shared, I'll check that and I'll share notes with you. You have to subscribe the Telegram group for that. Okay. Shall I continue? So in the previous lecture, basically, we got stuck here at the equilibrium because there was some electricity issue at my end. So what is equilibrium? If we talk in physics, the equilibrium, we can say that an object is in equilibrium if the net force, there are some conditions for the equilibrium which we have to keep in our mind when we are solving any kind of numerical. Because what is physics? See, understanding physics is very easy, but implementing those physics concepts in your numericals is somehow tricky. There is an art to apply those techniques. So I am an artist and I'll teach you each and everything that how you could able to apply those concepts which you have to study in this physics chapter. So basically, whenever somebody is talking about the equilibrium, you have to think in terms that equilibrium is all about the condition where I would say that f net is equals to 0. And if I'm saying that f net is equals to 0, I can divide this net force into multiple x's. Like I could say that the force in x-axis is 0, the force in the y-axis is 0, and the summation of the forces in z-axis is also 0. So I can extend this law and I can say that the summation of forces towards the x-axis is 0, summation of forces towards the y-axis is 0, summation of all the forces towards z-axis is also 0. So this is what you could do. And next, at a very next moment, you could also say is that we can say that an object is in equilibrium if the first condition is the net force at that point, at that object, on the object must be 0, And the next point is that the torque net must be 0. Right? If I'm talking about torque net is equal to 0, I could say that torque clockwise must be equals to torque anti-clockwise. So this is the condition which I have to keep in my mind. And basically, when we are calculating the torque, we usually calculate torque about a fixed point or about a fixed axis. Right? Let's see that which type of questions might come in your exam. This is a standard questions which we have to solve here. According to this question, there is a metal bar 70 centimeter long, and the weight of that metal bar is 4 kg, and it is supported by two knife edges. There are some students who got confused because of the word knife being used here in the question. Basically, it's not a knife which comes first in our mind, it's the knife edge. Knife edge means that the edge is only touching at one point, right? I could say that there is a triangle shape like this. So this is basically a knife edge, and on this knife edge I'm keeping one rod. If I'll keep this mouse on this, okay, so I can do one thing. You can consider one rod. The mass of the rod is 4 kg, and this rod is basically supported by the two knife edges placed 10 centimeter from both the ends. So I'm keeping one knife at this point and one knife at this point, okay, and the distance is 10 centimeter, and distance from here is 10 centimeter. A 6 kg weight is supported, a 6 kg weight is suspended at 30 centimeter from one end, okay, at 30 centimeter from the one end. So you could say that if you further goes 20 centimeter, there is a weight here of 6 kg. There is a weight of 6 kg, okay. Now find the reaction at knife edges. Assume the bar to be uniform, cross-sectional and homogeneous. Okay. Now we know that if this is a uniform rod, then there will be a center of mass of this rod. The complete length of the rod is 35 centimeters. So the center of mass will be at 35. So from here, if I'll further take 5, I'll further take 5 centimeter, there is one very special point which is known as center of mass, and I could say that this point will be equals to weight 4 kg is acting, so 4g you can say, and at this point 6g weight is acting downward, okay. Now we have to find out the reaction. So once this complete rod is touching at this point, this knife, there will be a normal force at this point. I could say that this is normal 1 and this is normal 2. Basically, you have to find out these normals, normal 1 and normal 2 in this question. So how we are going to proceed? My way of looking at the question is very simple. I Whenever I'm solving numericals of physics, I always see each and every data in terms of the forces, in terms of the energy, in terms of the work, in terms of the motion. So when I am having this diagram, I'm not that you do not have to see this diagram as given in the question. You have to see in terms of the forces. So I know that this object is not moving horizontally or vertically. So I could relate one thing. If I'll see that there is an equilibrium for the forces, I could say that force which is acting upward will be equals to force which is acting downward. So there are two forces which is acting upward, N1 and N2, and there are two forces which is acting downward, 6g and plus 4g. You can say that it's equals to 10g, or you could say that this is 100 Newton. So I'm getting first equation as N1 plus N2 is equals to 100. This is my first equation using the equilibrium of forces, because I know that if this metal bar is not moving. If it is not moving, then the force which is acting downward must be equal to the force which is acting upward. So first condition is done here. At the very next moment, what you have to do is, at the very next moment, what you have to do is, you have to take the condition for the torque. And for torque to be balanced, you must need one point at which you can find and compare the value of the torque. So I would making this point as a special point and consider this as point A, this as B, this as C, this as D. So torque at point A, I'm taking the net torque. Net torque is basically 0. So at point A, you can say that there is clockwise torque and the anti-clockwise torque. 5, 10, 35, 5 centimeter. So anti-clockwise, torque anti-clockwise is equals to torque clockwise, because the net torque is 0. So anti-clockwise motion is due to N2. So N2, and the perpendicular distance is from this A point to D point. What is the distance from A point to D point? The distance is 25 plus 25, 50. Is equals to clockwise. For the clockwise torque, we are having 6G into 20. And the next one is 4G into 25. You can substitute the value. $1,200 plus 25 into 400,000. 2,250 N2. N2 will be equals to 44 Newton. So N2 is 44 Newton, and if you replace the value of N2 here, you will get N1 as 100 minus of 44. So we get 56. Then this was the question. I hope that you got this. Sir, I am asking honestly. You are also ignoring. I am not ignoring anyone. Your Telegram ID. There is a link for the Telegram ID. T.me/IITJE Rankplus English. So you have to join that Telegram group. There you will get all the notes. Okay, Naveen? Warrior. There you will get all the notes. And I told you that you have to contact me after the class. So once this class is over, then only I can contact you, right? I'm not like other teacher. I am telling you that I'll help you. If your reason is genuine, I will definitely going to help you. So I hope that this question is clear to you. Let's move to the another question. So now we have a very, very important concept which we have to master, and the concept is known as the moment of inertia. This concept is very important because there are so many questions which have been framed using this concept. See, whenever you are solving previous year questions, the questions are not important for you. The most important thing is that you have to look for the concept, look for the topic, look for the pattern of questions which is coming again and again in the JEE exam. So if you started solving the previous year questions for the JEE main, and especially for the JEE main 2024, 2023, 2022, you will find that there are questions in every year based on the moment of inertia and the variations of moment of inertia. So basically, this is the heart of the chapter, heart and soul of the chapter. If you do not know this concept, you won't be able to solve the real questions which comes in your exam. So you have to master that thing. You know what? We have already studied the inertia. I told you that whenever you are studying this chapter, you have to relate each and every concept, each and every topic with the topics which we have already studied earlier. Like we have studied the kinematics, we have studied the Newton's laws of motion, we have studied the work, energy, and power. You always have to relate all those concepts with the topics which I am discussing. So you must know that what is inertia. Inertia is basically the property of an object due to which it resists the motion. So normally inertia resists the motion, and there are three types of inertia: the inertia of rest, inertia of motion, and the inertia of direction. You may be well acquainted with all those concepts, right? But here what we need to learn is that, is there any inertia being provided by the object to the rotation? Yes, object do provide inertia, or we could say that resistance, when we are moving the object, when we are rotating the object. So what is that inertia and how we can find out? For finding out the moment of inertia, the first thing which is required is that what is your fixed point or the fixed axis about which the object is rotating. So moment of inertia you cannot find out without signifying or without having a reference for the axis at which the rotation is happening. So first and foremost thing what you need to do here is, the axis of rotation is very important, or the point or the axis about which we have to find the moment of inertia. So I'm considering that this is the axis of rotation or axis of reference. It's a better word if I'll say that this is my axis of reference, axis, you could say axis of reference. And from this axis at a perpendicular distance r1, there is one mass of mass m1. Similarly, there is another mass m2 at a distance r2. And if you have to find out, or if you're rotating this object around this axis, is around this reference, the moment of inertia is very simple because it's a scalar quantity, and whenever we have to calculate the scalar quantity, you have to be very happy. Why? Because there is no much calculation involved. So here, if I'm going to find out the moment of inertia, the moment of inertia is that you have to take the mass and multiply it by the square of the distance. So it will be mr1 square plus, you just need to add m2 r2 square. So this is basically the moment of inertia if we are having the 2 points. We are having the discrete masses and the perpendicular distances are given. If anyone asks you that what is the SI unit for this, the SI unit, we can easily get the SI unit. The SI unit is basically the product of the unit for the mass. The unit for the mass is kg, and for the r square we have the meter square. So kg meter square will be the unit for the moment of inertia. I hope that this thing is clear. And if there is a continuous body, for a continuous body, what we need to do is, for a continuous body, this is for the discrete, this is for the discrete masses, and for a continuous mass, for a continuous mass we have moment of inertia is equals to r square dot dm okay. So we will I'll show you that how to get the answer. But here let's get the basics correct using the solution of this question. You know what? There are two methods to learn physics, or to understand physics better. The first one is to just get to the concept and then imagine that this concept can be applied here, this concept can be applied here, and this type of questions might come in your exam. You have to think on your own. The other thing is that you just have to get a brief description or the theory, and just after getting a brief theory, you have to move towards the practice session. You have to solve unlimited number of questions, you have to solve different patterns of questions, and you have to get the correct answers. So when you started solving various kinds of numericals, your confidence increases, and the way you started seeing the things is also getting changed. I always tell my student that if you really want to crack JEE exams and you have to crack JEE advanced, what thing is required is that you must be solving the Sudoku, you must be solving the puzzles, you have to play the chess games. There are some things which will improve your mental strength. So I suggest you to please include those things in your daily schedule as well. Let's say what's in there is what's there in the question. So in this question, there are three particles, each of mass m. There are three particles, and each of them is having a value of mass m. Are situated at the vertices of an equilateral triangle of side L. The sides are L. Find the moment of inertia of the system about the line AX perpendicular to the AB of. Okay. So assume that this is a triangle. I hope that this triangle is visible to you, as this is a transparent object. Okay. And I'm having one axis AX here, which is perpendicular to this side AB. So this is my axis. And if I'm taking this axis, that means that this object is rotating around this axis, right? And I have to calculate the moment of inertia. So you know what? Moment of inertia of three masses will be equals to m1 r1 square plus m2 r2 square plus m3 r3 square. I'm writing this thing, but when you are in exam hall, you have to do that thing manually or mentally. So this formula comes to my mind whenever I see these questions, and whenever I see that there are three masses, this comes to my mind immediately, right? And here you can do one thing. Consider this as m1, this as m2, or take A as m1, B as m2, and C as m3. Okay, so that thing is sorted, right? At least here we are having the same masses, so it doesn't matter. Okay, so I can do also one thing, that I is equals to, I can take m as common, r1 square plus r2 square plus r3 square. Why? Because every mass here is similar, identical. So I can take this mass as equal. Now I have to consider the distance as well. So r1 here is 0. Yellow may not be visible to you, so I'm taking which color? Red will be fine. So I have taken red. So r1 is equals to 0 here, r2 is equals to L, and what is r3 here? You have to tell me that what is the value of r3. Basically it's an equilateral triangle, then what is this r3? R3 is this, right? You have to take the perpendicular distance. And to take the perpendicular distance, can you say that if this is a equilateral triangle, so this point must be a midpoint of this side? So I can take that r3 is equals to L by 3. Are you able to get this? That how we can get these values, because these values are very, very important. If you didn't get these values, you will not be able to solve these questions, right? So what you need to do is, This was my formula. This comes to my mind immediately because if you are well trained, then the first thing which comes to your mind is that there are three masses, three discrete masses, and you have to calculate the moment of inertia. So this is the formula here. And at the very next moment, you must realize that what are the values for M1, M2, M3, and what are the values for R1, R2, and R3. And now, just you need to replace those values and you will get the answer correct. So M, this is 0, L bar L square plus L square by 4. So it's 4, 5. So I'll be getting 5 by 4. Mass is M and the distance is L. 5 divided by 4. Saksham Gupta, yes, I know. I'm from Delhi. So, but this actually, this YouTube channel is JEE Rankplus English, right? Rankplus JEE English. Here, basically, each and every teacher will teach you in English. Warrior, clear? Saksham Gupta, you just stay there and see what I am doing. These are very, very important topics. Warrior, is this thing clear? Can we move? Can we move? Can we move? Let's see. There is another question. This question is also very, very important, and you will see that if you are going to solve the previous year questions just for 3 years, you will get this question. And this question is from HC Verma, a standard questions, which I always take in my class. So according to this question, there are three particles and each of them is having a mass of 200 gram, are kept at the corners of an equator triangle of side 10 centimeter. You have to find the moment of inertia about an axis joining two of the particles and passing through the one of the particle perpendicular to the plane of the particle. Okay, let me do one thing. I'll give you one hint for the first one. Assume that there is a table. Assume that there is a table. And on that table, we are having an equilateral triangle. Okay, we are assuming that there is a table, and on that table we are having an equilateral triangle. There we are having three equal masses at all the vertices. We have to calculate the moment of inertia because I already told you that moment of inertia we need to calculate about something. So the axis is very important. Without axis, we won't be solving any question related to the moment of inertia. So the axis is that you have to join two of the particles. So I'm joining this particle and this particle. So if you join this and this particle, will get this, right? Now, if you rotate this particle, you know what? We know that moment of inertia is basically the product of the mass and the square of the distance. Here, what will happen? That both of these masses are on the line or on the axis which we have taken as a reference according to the question. So it won't come in our calculation. So this question is very, very simple. Just I need to get this value, and this is the height. So the moment of inertia for the first part will be equals to mass, and I'm taking this as h mh square. Are you getting my point? And you know what? For an equilateral triangle, what is the value of height? It's root 3 by 2. It's root 3 by 2a. So you could write this thing as m root 3 by 2 a whole square. So you will get 3 by 4 ma square. Now substitute the value 3 by 4. Mass is given to us 0.2. And the distance is 0.1 into point. Okay. So you will get 1.5 10 की power minus 3 kg meter square. Are you getting this answer? Saksham, it's not about it how many are studying. It's about that how many will get benefited. Once this lecture is over, they can watch this at any moment of time, right? This is a recorded sessions, you can watch it freely. So you must be thankful to me that I'm recording this lecture and this lecture will be available to you to watch at any time, right? This quality lecture is available for each and every student on this earth who, who wants to learn, who wants to know that what is the technique to get into the IIT, what is the technique to solve the numericals in the easiest way. So you must be thankful, right? And I must be thankful for the Rankplus that they are providing me this opportunity. I'm getting the money, but students do not have to pay for it. So it's a kind of thing what generally government do, a charity kind of work, which is Rankplus currently doing, isn't it? So see that. I hope that this question is clear to you and what is the real concept behind that. Here, what is important is the axis of rotation. So I am taking this as my axis. So if this is my axis here, so the only thing what you need to learn this is the ball here. So if this object is rotating, this axis is also rotating. Okay. I hope that are getting what is be done. Shall we move? Now, in the next part, I hope that now you can imagine that what we have to do in the next part, because in the next part they are saying that now your axis is basically passing through one of the particle and it is perpendicular to the plane of the particles. So if you are able to solve, if you are able to draw this, you can easily able to now get that what we have to do in our second part. So let me draw this diagram again for you. Here the axis of rotation is perpendicular. This is my axis. And if this is your axis, question becomes very, very simple, because there are two masses m and both of them are basically at equal distance from this. So you could write that I is equals to ma square plus ma square, and it will become 2ma square, right? Now put the values here. It's 2 into mass is 0.2, a square is 0.1. I can write this as 10 to the power of minus. So you will get I is equals to 0.4 to 10 ki power minus 2 kg meter square. This will be your answer. Are you getting this? Saksham, Warrior, Naveen, is this thing clear? Hari, Please do let me know. Is this thing clear? Do let me know. Are you able to solve this? Are you able to get that what we are doing here? Saksham Gupta, are you there? Okay. Let's move towards the next question. Here we have a very, very beautiful question. It is, in this, a particle of mass is 1 gram, 2 gram, 3 gram, 100 gram, so on. Means there will be 4 gram, 5 gram, 6 gram, 100 gram, are kept at the mark of 1 centimeter, 2 centimeter, 3 centimeter, so on a meter scale. So what is meter scale? Meter scale is basically a scale of 100 centimeter. Find the moment of inertia of the system of the particle about the perpendicular bisector of the meter scale. That means the perpendicular bisector is passing through the 50 centimeter. At 50 centimeter, this question source is HC Verma book. And if you started solving previous year question, you will find that there are multiple questions from HC Verma which comes directly in your JEE main. Directly means you do not have to like, even the options are not changed. Values are not changed. Saksham Gupta, what? KK, Garuda. I hope try to solve this question. Try to solve. You will get. Let me explain you this. Here there are some prerequisite. There is some formula which we have to know. According to this question, you can do one thing. There is one scale, and on this scale, we at a 1 centimeter we have one mass of 1 gram, 2 gram, 3 gram, 4 gram, 5 gram, so on, and like midpoint also. If you go, it will be better. And then when you go and the last, so at 1 centimeter, this is 50 centimeter, and this is 100 centimeter. 49. So here I can replace 1 gram, 2 gram, 3 gram, and this is 50 gram, 49 gram, 48 gram. There is a perpendicular bisector, and we have to calculate the moment of inertia from this point. You know what? To get the moment of inertia, what is required? We require a mass and the square of the distance, right? We require a mass and the square of the distance. So let me divide this portion into two parts. This is my left side, this is my right side. And if I'll calculate here, I will be having 1 centimeter. So I could write 49.1 square, or you could do one thing, just come here from this to this. You will be having 1.49 square, right? Or let me start it from here. 49.1 square plus 48.2 square plus, I'm starting from here, 47.3 square, so on, so on. At last, you will be having 2.48 square, 1.49 square. This is for the left side. And for the right side, this is for the left side. For the right side, you are having this plus 1.51.1 square. Okay. Then 52.2 square, 53.3 square, plus so on, so on. You will get 99.49 square and plus 100.100 square. So this is my moment of inertia. This was for the left side. And this was for the right side. Okay, and you know what? There is one formula which we have to use here. First, what I will do is I'll show you a similarity in this situation. What you need to do is you just have to recollect all the things. Like here we are having 1 square, here is also we are having 1 square. Here I'm having 2 square, here I'm having 2 square. So moment of inertia will become 49 plus 51, it will become 100. So 101 square. Then 48 plus 52, it will become 100. So there will be 100.2 square. Similarly, you will get 100. Okay, that is not 100. See. Similarly, you will get 100.50 square. If you take 100 as common, you will get 1 square plus 2 square plus 3 square, so on, till 50 square. And you know what? 1 square, I have to use one formula here. The square, the sum of squares. What is the formula? N plus 1, 2n plus 1 by 6, right? So I'm writing the prerequisite here. 1 square plus 2 square plus 3 square, so on, n square. It's n plus 1, 2n plus 1, n plus 1, 2n plus 1 divided by 6. So this is basically a formula which you have to use. Okay, n plus 1, 2n plus 1 divided by 6. Substitute the formula and get the answer. Please do let me know that what is the correct answer for this question. Do let me know what is the correct answer for this question. Saksham, Saksham, H. Solve this. So let me do it for you. 100 into the value of n is 50, n plus 1 is 51, 2n, that means 200, 200, no, 100 plus 1, 101. divided by 6. If you solve this, you will get 0.43. 0.43 will be the correct answer. I hope that this thing is clear. Warrior, is it okay? Shall we move? Let's move. Now, it's a time to get some basics correct regarding the moment of inertia for the continuous body. To get the moment of inertia for the continuous body, what there is some basic steps what we need to follow, and I'll teach you that what are those basic steps. But I want you to please remember all the steps and also remember the moment of inertia formula for the quantities which you have to, right? I'll be writing each and everything in a simple format so that the learning must be very easy for you. Shall we do? Shall we start? Okay, let's start. First thing first, the moment of inertia, the formula to get the moment of inertia of a continuous body, the formula is I will be equals to r square dot dm. So this is the formula which you have to use. And but there is a technique to apply those formula, and the technique will be equal, or I would say it is similar to what we have already studied in the center of mass, right? So let me take very basic example. If there is a uniform uniform mass rod, there is a mass m, and let me say that we are rotating this object from this. Okay, this is my axis of rotation. The length is L. This is my origin point, O. Now, first thing first, what is your first step? The first step is that we have to take an element. We have to take an element. Step 1. Take an element. At a distance x. So let me take an element here of mass dm at a distance of x. Okay. So element is done. Step 2. Find dm. You have to find dm, and to get the dm, very simple strategy. We will be using the what we say unitary method. So we know that for a length L, we have mass m. For a length L, we have mass m. For 1 unit of length, we have mass of m by L. And for a length of dx, we have mass dm. That will be equals to m by L of dx. Okay. Now, this thing is done. Now, this thing is done. What is step 3 here? For step 3, what you have to do is you have to use the formula of moment of inertia. Calculate the MOI. Moment of inertia is also known as MOI. So calculate MOI using formula I is equals to r square dot em. So let me put the values here. What is the value? I r square, I'll be taking this as x square dm, and distance will be 0 to L. Okay. Now m by L x square dot dx 0 to L. So moment of inertia, you have to integrate it. Integration will give you x cube by 3. Put the value of L and 0 here. You will get ml square divided by 3. So this is basically the moment of inertia once we are rotating the object or a rod from its one of its end. So when I am rotating a rod from one of its end, the moment of inertia is ml square divided by 3. What does it mean? I'm having a rod here. So I'm having a rod here. So if my axis of rotation is at one end like this, and I'm rotating this rod like this, so the moment of inertia of this rod is ml square by 3. So this is basically the moment of inertia of this rod. But what will happen if I'm rotating this object from this point? So this moment of inertia will get changed. Let's see that how it will get changed. I hope that this is clear to you. Is this thing clear to you, my dear? Please do let me know. If there is any doubt, you can ask immediately. You know what? Doubt kills more dream than the failure ever will. Because once you are fail, you can rise again. But if you are having a doubt, then what will happen? The doubt will come again, right? So you have to ask your doubts. You have to be clear with your doubts. That is why I'm here. I hope that this thing is clear to you. Let's move towards the next moment of inertia of a rod. So in the first, it was a case A at one end. Or about moment of inertia about axis at one end. I was having a rod. Rotate this rod. The moment of inertia, if the length is L, the moment of inertia about this rod will be equals to ml square divided by 3. The mass of this rod is m, right? So this is done. We have derived this formula. Now let's do it for another kind of a situation or a geometry. Moment of inertia about midpoint of a rod, or we could say perpendicular bisector to the rod. Now I'm changing this axis. I'm moving this axis to this part. Now what will happen if this is my point O? If this is my 0 point, that will be plus L by 2, and that will be minus of L by 2, right? That will be plus L by 2 and minus L by 2. Now to get the moment of inertia, what I need to do is I have to multiply it by 2. My moment of inertia will be 0 to L by 2. r square, or you can take one element here at a distance of x. The mass is dm here. So x square dot dm, right? Dm we already have find out that dm will be equals to m by l dx for this situation. So you can replace this value here. So you will be getting 2 m by l x square dot dx, and the value is going from 0 to l by 2. So if you solve it, you will be getting 2 m by l x cube divided by 3. Right? But this time we have to replace the value as l by 2 and 0. So 2m by l 2m by 3l into l cube divided by 8. ml square divided by 12. So in this situation, we are having another formula for the moment of inertia. That moment of inertia is coming out to be I is equals to ml square divided by 12. So two different situation, two different formulas we are getting. I hope that this condition is clear to you. Now there is another condition for this simplest rod equation. What will happen if I'll tilted this rod? What will happen? I shorten this. It's not allowed. So I'll take another form here. Rod. C part. Axis of rotation is this. The length is L. There is theta. And the moment of inertia is I. And you have to calculate that what is the moment of inertia when this rod is rotating. To get the moment of inertia, I always tell to my student that you have to think in terms of what I am teaching to you. Okay, you have to think in terms of what I am teaching to you. So here, what you need to do is, you just have to think that sir have told us that if this is an axis of rotation, and if this is a rod, and if we are rotating it, if this is the x of length and the mass is m, then the moment of inertia about this will be equals to m x square divided by 3, right? This was the formula which we were having here, the ml square divided by 3. So similarly, what is different here, if I'll resolve this, I'll not be disturbing the diagram given in the question. What I'll do is I'll take a separate diagram, and if I'll resolve this, what will happen? If I'll resolve this, that length will be equals to L sine theta, and that length will be equals to L cos theta. And you know that this length will not give you any moment, any inertia for the rotation. So my required inertia will be equals to, the mass will remain mass. So my moment of inertia will be equals to m L sine theta square divided by 3. that is the formula. I hope that you are cleared with this formula or the methods which we are using here. Is this clear, my dear? Please do let me know. Okay. Now, similarly, let me give you one question and say that if you are able to solve it, then it's very good. Assume that this is the axis of rotation at a length L. At a length L far, we have a rod of length L. Okay, and you have to calculate moment of inertia of this rod. Find the moment of inertia. Calculate the moment of inertia and do let me know what is the value here. I'm giving you 1 minute. Let me share this session again. Yes. Have you done? Now, there are some theorems which we can use directly when we have to solve this type of question in our exam. But now, I want you to be 100% sure about the steps which we have done, about the derivation. So, in this, what we need to do is, we have to calculate the moment of inertia. For getting the moment of inertia, I need to take an element. Let me take an element here, and this element is having a mass of dm, and this value is at a distance of x from the axis where it's rotating. So to get the answer here, my moment of inertia will be equals to x square dot dm, right? And dm, you know that dm for the rod is m by l dx, the small distance we are having. The important thing is that what we need to do about the limits we are having here. The limits usually here starts when the rod starts, so it goes from L to 2L, isn't it? The limits here in this question will goes from L to 2L. Why? Because the rod is actually starting from the length L. This is the initial point and this is the final point. And now let's solve. If you put this value here, you will get m by L x square dot dx, and this is going from L to 2L, right? There is very simple integration. Even if you do not know the integration, just know that you increase the value of, increase the power of x and divide it with the same power. So you will get m divided by 3L x cube, and you have to replace 2L and L here, right? So moment of inertia, I'll be getting m divided by 3L 8L cube minus of L cube. the moment of inertia will be equals to 7 ml square divided by 3. So this is the formula which we are getting. I hope that this thing is clear to you. Warrior, Hari, is this thing clear, my dear? Very, very important. It was. I hope that this thing is clear. Clear? Let's move. Shall we move towards the next point? Or shall I wait? Wait. Shall I move? Okay. Now, similarly, there are two theorems. Before we proceed with the questions, here, once we are done with this moment of inertia topic, there are so many questions lined up one after the another. So, there are two basic theorems. Or I would first discuss the moment of inertia. Common shapes. First one is of rod. So for rod, uniform rod, at this point, the moment of inertia, mass is m, length is L. The moment of inertia is ml square divided by 3. And if you need to find out here, it's ml square divided by 12. Okay, these two formulas are very, very important. And you know what? There is another theorem. There is another theorem out there, which is parallel axis theorem and the perpendicular axis theorem. Theorem for moment of inertia. So for moment of inertia, we have two important theorems. First one is the parallel axis theorem. And the another one is perpendicular axis theorem. Parallel axis theorem and perpendicular axis theorem. What does parallel axis theorem says that if there is a body, and in this body there is, we know about the mass is m, and we know that this is moment of inertia of center of mass. What if I'll shift this axis by a distance of d? What if I'll shift this axis by a distance d? Then my moment of inertia at this point will be equals to mass of this object is m. My moment of inertia will be ICOM plus the total mass and d square. You can verify this using this thing. As we know that this ml square by 12 is the moment of inertia at the center of mass, right? Because moment of inertia of center of mass is very, very important. And if I need to verify this parallel axis theorem, I can do one thing. I can imagine that this center of mass, this axis at the center of mass is shifted by a distance of L by 2. And to get that value here, I could say that it's ICOM plus M and L by 2 whole square, right? So you can write it's ML square divided by 12 plus ml square divided by 4. take an LCM here, 3 and 3. So you will get 12, 4 ml square will get cut. I is equals to ml square divided by 3. I hope that this thing is clear to you, and we have verified this using the parallel access theorem. Now again, here for a perpendicular axis theorem basically says that if there are 3 axes for this, I want you to draw one table to have a better understanding of the axis that at which point we are talking about. Let me color this table. I'm very good at coloring. So this is done. Now there is an object. If you calculate the moment of inertia about this axis, I'll take this axis as Ix. If you calculate here, I'll take this as Iy. This is Iz. So perpendicular axis theorem says that Iz will be equals to Ix plus Iy. Okay. So this is about moment of inertia. I hope that this thing is clear to you. Is this clear, my dear? Please do let me know. Hey, yaar, where are you all? Are you having any kind of exam now? Why you are not joining? You know what? Attending live class is very, very important. If you do not attend live, then what will happen is that your backlog will be more. I hope that this thing is clear, right? Now, let's move. Now, there are some, like I was telling you, that you have to remember there is a trick. Remember moment of inertia. See, I'll be sharing the tricks only for those topics where I know that student faces issue while remembering the formulas. So for the moment of inertia, you know, there are so many shapes out there in physics and there are so many formulas, but is that all formulas are important for us? No, not all formulas are important, right? So to remember this thing, there is one line which I'm putting here. You only have to remember Rocky Rani, solid scene. Rocky Rani, solid scene. So what does it mean? It means that Rocky stands for the rod. You have to know that what is the moment of inertia of the rod. Rani refers to the ring. Basically, if you have a Rani or queen, you have to like they usually wears the rings, right? Even I wear the ring. So for the solid thing, there is third thing, that is the king of moment of inertia formula, especially for the JEE exam. That is solid sphere. And if I'm talking about this is your hollow sphere. This is your hollow sphere. And using this, I could say that you can easily find out moment of inertia of any other kind of the shapes which you will get, right? Rod we have already done. Let's now solve it for the ring. Rod we have already done, right? So these are the only things which you have to do. For rod, you only have to remember the formulas which I have put you. Let me copy it from here. Let me copy it from here. So this is the formula for the rod. So this is the formula for the rod. And let's now for the ring. This is radius r, the mass is m. The moment of inertia is mr square. Very simple. The moment of inertia of ring is mr square. Now, you know what? What if I'll break this? What if I'll break this ring and I'm having a semicircular ring? What if I'm having a semicircular ring? The radius is r only. This is mass. The moment of inertia will be equals to mr square. R, take it as capital R. The moment of inertia will be equals to mr square. Now at any angle, like if I'm taking the mass as m, the moment of inertia will remain same. Even if I'm taking a segment, even if I'm taking a segment here, the moment of inertia, if I'm considering the mass as m, the moment of inertia is mr square. Okay. So it doesn't matter that what happens to the ring. The important fact is if there is a mass, the total mass is m, and it is at a distance of r at every time, the moment of inertia will be mr square. I hope that this thing is clear to you. Is this thing clear, my dear? And now the important part is that what will happen if I'll take this axis to this axis. If I'll change this axis to this axis, the moment of inertia using the parallel axis theorem, I hope that you remember the parallel axis theorem. Using the parallel axis theorem, we know that using the parallel axis theorem, just what we need to do is you have to remember the moment of inertia about the center of mass and you have to add them up, right? So here I can do one thing. The moment of inertia is moment of inertia about the center of mass, and we have to add this. So I'll take this as 2mr square. So my moment of inertia will become this. And let's extend this thing. What if I have to calculate the moment of inertia at this axis? What if I have to calculate the moment of inertia about this axis? This moment of inertia will be mr squared divided by 2, right? Both of them I have to take. Now, I hope that this thing is clear. Now, if there is a slender, hollow slender, the moment of inertia of hollow cylinder will also be same. If this is a hollow cylinder, the mass is m, the moment of inertia is mr square. I hope that this is clear to you. And for a ring, for if you know about a ring, I would suggest that you must know about the disk as well. You must know about the disk as well. For a disk, it will be mr square. But if you if you go for if I'll say that if you go for a JEE exam, then what are you saying, Tanishk? Yes, mr square, right? So I told you that this is basically a trick, Rocky Rani solid scene. This is very important trick, because you will find that in your JEE exams you will get only these types of shapes. You do not require to remember the shape for a cone. You do not need to remember the shape of a frustum type. There are formulas for that, but you do not required for the JEE exams. Even for the advanced, that if that comes, you have to derive it. You must know that there is limitations, right? And you must know that what are your limitations. Let's move towards the next part. 1 and 2 is done. Third one. Third one is solid sphere. If I am having a solid sphere, the moment of inertia of a solid sphere is 2 by 5 mr square. And if you take this axis to this point, your moment of inertia will become 2 by 5 mr square plus mr square, 7 by 5 mr square. I hope that this concept is clear to you, right? And the next thing is hollow sphere. Hollow sphere. Moment of inertia is 2 by 3 mr square. Okay, it's 2 by 3 mr square. And if you shifted this axis, this point, your moment of inertia will become 2 by 3 mr square plus mr square. And you could write this as 5 by 3 mr square. And now you know that you are done with the moment of inertia which I have to tell you. Now only thing which is left is that your questions which you have to solve. Okay, Tanishk Mishra, where are you from? Tanishk Mishra ji, where are you from? Now there is another concept which is known as radius of gyration. There is another concept which is known as radius of gyration. So what does radius of gyration means? Radius of gyration means there is an object of any kind of shape. I'll take it this kind of shape. This is the only random thing which I can draw. And let me assume that there is one axis out there. And the moment of inertia is I. What if I have to transform, or I have to compare this with a ring? What if I have to compare its moment of inertia with a ring that is having a radius of k? I'm having a ring of radius k. If this object is having a mass m, this ring is also having a mass m. Now what will happen? I know that the moment of inertia of this ring, I know that the moment of inertia of this ring is mk square, right? So from this to this, we can do the comparison. Basically, in radius of gyration, what we are doing is we are taking any object, irrespective of its shape. We are comparing the moment of inertia of any object with the moment of inertia of a ring. A hypothetical ring, we are comparing it with a hypothetical ring, and the radius of that ring is known as radius of gyration. So from equation 1 and 2, you can do one thing, that I is equals to mk square. So k will be equals to I by m under root. That is the radius of gyration. That is the radius of gyration you are having. Okay, so now basically we are done with whatever I have to teach you. It is very simple concept. Just what you need to know is that how you are going to apply, right? Now let's move forward. You know what, generally we have a translational system. We have a translational system with us. And there is a rotational system. There is a translation system, there is a rotational system. Kinematics we have already done in the previous class, in which I have shown you that how we can replace the normal displacement with the angular displacement, how we can compare the normal velocity with the angular velocity, how we can compare the acceleration with the angular acceleration, and how we can extend the use of equations of motion in the rotational kind of data, right? We have already completed that. Now the important format is, now once we are done with the kinematics, which includes the motion in a straight line and the motion, basically what I am doing is I'm relating all the concept what we have already studied in this chapter. So we are done with the kinematics that includes the two topics, the motion in a straight line and the motion in a plane, right? So we have already done that in the previous class. Now in this class, what comes next? What comes after kinematics? It is the laws of motion. So in laws of motion, what we have to do is, we have force, right? We have force here, but in rotational we have torque, and you know that torque is equals to r cross f. We have to do the cross product of two different scenarios, r and f, to get the value which is required. Also we know that force is equals to mass into acceleration. So analogous to that formula, in torque, we are having that torque is equals to mass will be replaced by moment of inertia and A will be replaced by alpha, right? See, science is the deadly enemy of uniqueness. You do not have to see the uniqueness in every concept, whatever you are studying. You have to see a, a similarity. You have to see the general things when you are solving or when you are reading. So we know that force is equals to mass into acceleration and torque is equals to I alpha. This is very important concept which you have to remember. Now, once we are done with the force, we also know that force is, there is another formula for the force, and force is equals to dp by dt. I hope that you remember the second law of motion of Newton. So here torque will be equals to dl divided by dt. What is dl here? Basically momentum. If we say that momentum is the product of mass and velocity, here angular momentum L is equals to I omega. L is equals to I omega. And another thing what you need to know is that how we are going to calculate the L. The other formula is L is equals to R cross P. L is also equals to R cross P to have a relationship between the rotational and the translational. So this is for the forces chapter. These are the concept which is required. And we know that when there is no external force being applied, so if there is no external force, I could say that dp by dt will be equals to 0, or I could say that there is a conservation of momentum out there. If there is conservation, there is no change in the momentum. And similar to that, if there is no torque, no external torque is there, I could say one thing, that dl by dt will be equals to 0, right? You can do one thing for that. And for that, here I omega will remain constant. If L is constant, I omega will remain constant. What does it mean? It means that if I'll increase the moment of inertia, my speed will decrease. I will be moving at a very less speed. But if I'll take all these objects near to me, then my moment of inertia decreases, and due to this I will move fast, right? You must have seen that experiment. I have already performed that experiment on this YouTube channel. If you haven't seen that, please watch that in the playlist. So I'm telling you that science is the deadly enemy of uniqueness. And what does it mean? It means that you do not have to see everything as a unique. See everything as a generalized term. And here what I'm doing is I'm relating each and everything, each and every concept, whatever we have studied earlier in this chapter. Similarly, you have to analyze that this chapter is not unique. This chapter is basically an extension of whatever we have studied earlier. Just new concepts are there that you know. There is center of mass. You must be well acquainted with the center of mass. There is moment of inertia. You must know that there are certain values of moment of inertia that you have to remember, right? It's not that you will say that I will not remember those formulas because those formulas will be for a Rattu Tota, and I'm not a Rattu Tota. I'm a kind of a student who wants to know that what is the real concept. It's not like that. Once you become an IIT and whatever you say, the people will follow it, right? So I told you that you have to remember that what are the important shapes of which you have to remember the formulas. So trick is very simple. You just need to remember that Rocky Rani solid scene are there. Rocky Rani solid scene are there. And for the Rocky, you need to remember that there is a rod. For a Rani, there is a ring. For a solid, we have a solid sphere. For a scene, we have a hollow sphere. So these are the values which you must remember. Other than that, you must be well acquainted with two theorems, the parallel axis theorem, the perpendicular axis theorem. And I will bet you that you will be able to solve each and every question. The radius of gyration terms is also coming. And the next thing is that you will be able to relate the concept. Now, once we are done with the forces and the laws of motion chapter and all the relations are established, now it's time to get to the next moment. What is the next moment? The next moment is about the work, energy, and power chapter. So for a work, we know that work is equals to force displacement. It's a product of force and displacement. Here also, if I'll talk about work, so work will be equals to torque dot theta. Okay. And if you talk about power, or I'll say about energy, let me talk about kinetic energy. Kinetic energy is equals to half mv square. Here, rotational kinetic energy is equals to half I omega square. Okay, I hope that this thing is clear. And like for a different object, you have different moment of inertia. For a different object, you have different moment of inertia. You have to replace those values. And that is what all we have to study in this chapter. Let me show you. Let me show you the topics which we have to cover. See the topic here. The first thing which we have to discuss in this chapter is the basic concept of the rotational motion, that why this rotational motion or a circular motion, the basic difference between circular and rotational motion, what is the basics for the angular displacement, angular velocity, angular acceleration, and the relationship between that. We have already completed this topic in our first lecture, the first part. Unfortunately, I have to divide one shot into two shots. The reason was there was electric fluctuation at my end during that time of the previous class. The second thing was moment of force and the torque. We have solved like 3 or 4 questions on that torque, right? The third thing is angular momentum, L, conservation of angular momentum, I omega is equals to I1 omega 1 is equals to I2 omega 2, and its approach, it's very, very important. This is what I told you. Next one is the moment of inertia, and see the beauty of the syllabus. See, it's telling you the moment of inertia, the radius of gyration, and the values of moment of inertia for simple object. They are not telling you that for how many objects you have to learn. For how many objects you have to learn. And what happens, right? What happens is that if I'll teach you many objects, if I'll teach you the moment of inertia of many objects, you will see that, oh, sir, my sir have taught me these many objects, but these objects are not coming in exams. It might also happen, right? So I'm not here to show my knowledge. I'm very much knowledgeable. I'm having a decade of years of experience, and I'm taking 5 to 6 batches daily for this topic only. So I know each and every concept, each and everything. But what is important for you is to get the selection. And for getting the selection, it's not about that how much you know. It's about that how much you can show, how much you can do in your real exam. So you have to know the simple geometric objects. And I have shared the trick with you, Rocky Rani solid scene, and you will remember that trick, right? Next one is the parallel and perpendicular axis theorem and their application. We have completed this also. For the equilibrium of rigid body, I told you that there are 2 conditions which you need to keep in your mind. The net force must be 0, the net torque must be 0. For the rigid body rotation and equation of rotational motion, we have already done this. And the comparison of linear and rotational motion, we have completed this, right? Now it's all about my approach, that what is my approach and how I am going to solve the numericals. It's very, very important, right? So that is why I have kept that special thing in the last, because there is an approach which I generally use, and my students do not face any issues while starting to solve numericals, irrespective of the topic which they are doing. It's like even if it's for kinematics, laws of motion, rotational motion, which usually a student faces an issue while solving the numericals. So I'm telling you that my student never faces issue while solving the numericals. Why? Because my approach is very unique. My approach is that if you do not have any plans, you have to search for the extreme end, right? And if you are searching for the extreme end, you can get the answers correct. You have to relate those functions, relate those formulas with multiple things, so that you can remember, you can hit every neurons, you can use every neurons, whatever you are having, and you can relate those neurons, right? So I told you that basically in this chapter, in this rotational motion, we are not studying new concepts, we are not studying all. Basically what we are doing is we are revising, we are extending whatever we have studied earlier in a special type of motion, which is rotational motion. The only new things which comes in this is that there are new terms for the displacement. We replace it by angular displacement. Velocity, we replace it by angular velocity, right? These are some important terms. And the another term was the that moment of inertia, center of mass. So these are the only terms which we have to study in this. The only thing is that you have to relate those concepts with the others. Now it's time to solve the numericals which have come, which had come in your JEE 2024. So let me start solving the numericals. We have completed the full syllabus for the rotational motion. I wanted to complete this in one shot, but unfortunately, in the previous class, there was some issue for the electricity at my end. That's why I was not able to do that. Warrior, sir, I'm asking your Telegram ID. My Telegram ID is I'm writing it for you. It's I am underscore Manoj 24. Okay, Warrior, this is my ID. Shall we move? Okay, this is a question from JEE 2024 4th April shift 1. And when this question comes, usually there was lot of teacher was saying that this question is out of syllabus question, because this question is directly related to the rolling without slipping, right? They are saying that rolling without slipping, and there is rolling was excluded from the JEE syllabus, but they have given us the question from that. I hope that you can now solve this question, and do let me know that what is the correct answer. Do let me know that what is the correct answer. Solve, guys. Warrior, is it done? You have to solve, Warrior. You have to solve it. Will you be able to solve it? See, in this question, what is they are asking? There is a solid sphere and a hollow cylinder. There is a solid sphere and a hollow cylinder. And what is happening here? I'm taking a solid sphere of mass m. It's moving with a constant speed v. Okay, the same initial speed is given to us, that they both of them are moving with same initial speed. So there is solid sphere, and at this point we are having a hollow cylinder. This is also moving with speed v. Now rolls up without slipping on same inclined plane with the same initial velocity. The sphere and the cylinder reaches up to a maximum height of h1. So this, let me consider that this has reached a height h1. This is h2. Okay, Now you have to find out that what is the ratio of H1 and H2. Once this object is moving, this object is having a kinetic energy, and this kinetic energy will be equals to half mv square plus half I omega square. How many of you agree with this? And at this point, once this object reaches the maximum height, it will be having only the potential energy, and this potential energy will be equals to mgh. So my kinetic energy will be equals to half mv square, v square is same, plus half I. What is the value of solid sphere moment of inertia? It's 2 by 5 mr square. So I could write this as mr square, right? And the value of v is equals to r omega. So omega I could replace it by v by r. So it will be v square by r square. You can cut this. 2 and 2 will cut. So you will get half mv square plus, I'll replace this mass with m. mv square by 5. Okay, now solve this. Take an LCM. 10, 5 plus 2, 7 mv square. This is my kinetic energy. This is my kinetic energy for this one. See, whenever I'm seeing any questions, my simple approach is, if you do not have any plan, search for the extreme end. So my extreme end is what is at the starting point and what is at the ending point. So at starting point, I'm having the kinetic energy. At ending point, I'm having the potential energy. So just you need to compare this thing first and second. So if you will compare, you will get so this is what you are getting. Right? Similarly, at this point, you are having here the potential energy. Potential energy is mgh2. Mark this as 4. And here kinetic energy is equals to half mv square plus half I omega square. Half mv square plus half. Moment of inertia is mr square. Very, very easy here. Mr square. And you can replace this by v square r square. Just replace. We'll get mv square 5. From 4 and 5, and h1 by h2 will come out to be from equation 3 and 6. We get from equation 3 and 6 we get h1 by h2 is 7 by 10. This is my value of n. Here the answer is 7. Here the answer is 7. I hope that you know that how we are going to approach this question. Is this thing clear, my dear? Please do let me know. Is this thing clear, my dear warrior? Tanishk Mishra. Let's move to the next question. Solve this question. I'm giving you 2 minutes here. Solve this. Solve this question. In this question, you have to find out the ratio of radius of gyration of a hollow sphere to that of a solid cylinder, hollow sphere, to that of a solid cylinder of equal mass for moment of inertia about the diameter axis AB is shown in figure is under root 8 by x. The value of x you have to find out. Okay. Question is very conceptual. Hollow sphere 2 by 3 mr square. And if you need to find out the radius of gyration for this, it will be root 2 by 3 r, right? Let me take this as 1. I hope that this thing is clear to you. Right? For the next part, which is very, very important. For the next part, we have like this is rotating at this point. So I can consider this as one rod. And if this is a rod, then what will happen? The center of mass will be for a rod plus center of mass for a disc. For a rod, I will be considering the mass is m. L is 4r ml square divided by 12. And for disc, I have m r square by 2. I hope that this thing is clear. Okay. Is it clear? Okay, this is a solid. For solid, you could have to take it 4. Multiplied by 3, multiplied by 3. You will get I1, I2. Teen. 19 by 12 mr square. So this was K1. And for K2, so K1 by K2 will be equals to under root 2 by 3. So that is coming out to be 8 by 19. So 8 is already given. So comparing this and this, you will get 19. Are you getting that? Something somewhere there is some mistake. mr square by 12. Okay. Yes. What are you getting? What are you getting? Are you not getting this thing? Please let me know. Okay, okay. I have missed something. I have to include one more thing here. Plus m r square. So that will be I2 will be equals to 16 mr square divided by 12 plus mr square 3 mr square divided by 12 plus 4 mr square, and I'll do one thing. I'll multiply this by 12. 12 4 is 48. Now 48, 51, 67. So it's 67 mr square divided by 12. Okay, now it's fine. So if I need to get it, if I need to get the K2, if I need to get the K2 here, K2 will come out to be 67 divided by 12 R. Okay, now the answer is this 67. This is your answer. I hope that you got the same answer and you didn't make the mistake which we were having while we were doing the calculation. Is it clear, my dear? Is it clear, my dear? Please let me know. I hope that it's fine. Now let's move towards the next question. Now let's move towards the next question. In this question, basically, we have been provided that a hollow sphere is rolling. A hollow sphere is rolling on a plane surface about its axis of symmetry. The ratio of rotational kinetic energy. So they are asking you the ratio of rotational kinetic energy to kinetic energy of total. Rotational kinetic energy is equals to half m half I omega square, and it's equals to half I omega square plus mv square. Okay. Now, moment of inertia of a hollow sphere is 2 by 3 mr square. So you can replace this 2 by 3 mr square. We will keep this omega square as omega. Or you could do one thing. You can replace this omega with v square divided by r square. This and this will cut. 2 by 3 my square c 5. So we are getting 2 by 5. So the value of x, what is required is 2. I hope that it's clear to you. Sir, explain once again, Srimada Jamalpur. Okay, so first of all, here we have been provided that there is a holosphere, and holosphere is rolling. So when the holosphere is rolling, it is having two types of kinetic energy. The first one is the rotational, right? If this is my sphere, a holosphere, consider this as a holosphere. If this is rolling, so it's having a rolling kinetic energy, plus it is also having a uh, the translational kinetic energy. For the rotational energy, we have formula half I omega square. Kinetic energy is the simplest form of energy because its formula does not get changed. And the moment of inertia for the holosphere formula is 2 by 3 mr squared. This is what I changed here. And we know that V is equals to R omega. So V is equals to R omega. So that is what I have replaced it here. So after solving this, we are getting this thing. And I told you that we have to remember formulas for moment of inertia only for these shapes. And this is a trick to remember those formulas. You have to remember Rocky Rani solid scenes. Rocky stands for rod, Rani stands for the ring, and solid scene stands for the solid sphere and the hollow spheres. So these are very, very important. And please do watch this lecture completely if you really want to revise the moment of inertia and the concept which is required to solve the rotational motion numericals. And I'm here solving currently your JEE 2024, each and every questions I'll be solving. I hope that this thing is clear to you. Is this thing clear? Please do let me know. Srimada, is this thing clear now? Please do let me know. Is this thing clear now? Okay. If this thing is clear, let's move towards the next question. This question is from JEE Main 2024, 6th April shift 1. The question says that if the radius of the earth is reduced to 3/4, so let me assume that we have our planet, the blue planet we are having, and there is earth, it is reduced to 3/4. Radius here is r, radius here is 3 by 4 r. Okay, that is basically the difference what we are getting here. To its present value, without change in its mass, the mass will remain same. The mass of this is m, the mass of this is m. Then they are asking you, then what is the value of the duration of the day of the earth will be this much hours and this much minutes. So they are asking you to find out the hours. Hours only you have to fill. So you know what? Here I could do one thing. If this is rotating, this earth will also get rotate. And if there is moment of inertia I1, it is rotating at us omega 1. It's I2, omega 2. I could compare the moment of inertia, or I could compare this thing. So I could tell you I omega 1 will be equals to I2 omega 2. I1 will be 2 by 5, 2 by 5 m r square. Omega 1, see, omega is equals to 2 pi by t, right? So I could replace this 2 pi divided by time period. And for this thing, we have 2 by 5 m. R gets changed. Here r is 3 by 4 r square, and it's 2 pi divided by t2. You can easily cut all these things. Excess garbage will be removed. And we have to find out t2. So t2 will be equals to r square will also get cut. So t2 will be equals to t1 multiplied by 9 by 16. I hope that this is clear to you. And you know what? We have very simple duration, 24 hours into 9 bar 16. So 8 to the 16, 8 to the 24. 27 divided by 2. We are getting 1, 3.5. So 13 hours you are getting. You are getting 13 hours. The answer is 13 hour 30 minutes. You have to replace this 13 hours. Are you getting? Mom's Grace, hurry, hurry, you are so late. We have started to solve previous year questions. I have already discussed the concept which was required to solve. See, I'm a kind of a teacher who believes in teaching very few concepts and making you so fine in that concepts so that you can apply in any concepts, in any questions. Whenever you get the questions, you are able to apply the concept, you will able to start initiate the question. You will not feel that I am not getting the approach. You will get the approach. If you are regular to my classes, you will 100% you will not face this issue. So these were the topics which we have to cover according to the JEE Main 2025 syllabus. I've already discussed all these concepts, and now basically I'm showing you that how to apply those concepts what we have studied in the real exams questions. So let's move to the another question. Here, this question is from JEE Main 2024, 6th of April, shift 2. JEE Main 2024, 6th April, shift 2. According to this question, it is saying that there are three balls of masses 2 kg, 4 kg and 6 kg respectively are arranged at the center of the edges of an equilateral triangle of side this much. You have to find the moment of inertia. You have to find the moment of inertia, okay, of the system about an axis through the centroid and perpendicular to the plane of the triangle will be. Now, you know, if you see the question, you only see the question. But what I am seeing is I am seeing the pattern. Is this question isn't similar to the question which I have already discussed you, and this question was from HC Verma book, right? This question is similar to the questions which we have already discussed. See this question, there is a equilateral triangle out there, the masses were same. You have to find out the moment of inertia about the line joining the two masses, and at the next moment of time you have to find out the moment of inertia about axis which is perpendicular to the plane and it is passing through one of the mass, right? So this was what we have already done, and this question is from JEE 2024. So now attempt this question and do let me know that what is the correct answer here. You have already done a similar type of question. Start solving. You know what? The value of this is equals to a by root 3. The value of this r is a by 3. I hope that you remember this thing. You remember this thing? It's very easy. You know that the basically it is divided into 2:1 part. If this is a triangle and I'm considering this as a centroid, the centroid is divided into 2:1, and the height formula is root 3 by 2 a, I'm considering each side as A. Okay. Now, you know that when there is a ratio, I can consider this as 2x plus x is equals to root 3 by 2a. You can replace this 3x is equals to root 3 by 2a. The x will be equals to a by 2 root 3. And here you are required to have 2x. So that will give me a by root 3. Right? Now, this is also r. This is also r. The masses are different, m1, m2, m3. The moment of inertia will be equals to m1 plus m2 plus m3. Distances are same, r square. And 6 plus 4, 12. 6 plus 4 plus 2, 12. 12 kg into r square, I could write it as a square divided by 3. 4a square. So 4 into 4. You are getting 16. Are you getting that? Please let me know. Are you getting this thing? Sir, physics is very, very tough. Huh? Rathai Kamal. No, it's very easy. If you started seeing in the pattern, you will remember that this is very, very easy. And if you are missing the patterns, you will realize that it's very, very difficult. Right? I hope that this thing is clear to you. Let's move towards the next question. Next question is a thin circular. We have a thin circular disk of mass m and radius r is rotating in a horizontal plane about an axis passing through its center and perpendicular to the plane with angular speed this much. Okay. If another disk of same dimension but of mass m by 2 is rotating m by 2 is placed gently on its first disk coaxially, then the new angular velocity of the system, what it could be. Now, what must be your approach in solving this? You let me know. Rathai Kamal. Okay, have you done it? And you were saying that physics is very toughest subject in JEE. See, the basic difference is between a student who got selected and between the student who got rejected. Is that student who got selected basically knows that which type of questions will come in the exams and they will study according to the question paper. But the student which is very, very intelligent but do not study according to the questions which is coming in the exam, they study accordingly according to their own instinct or according to their kind of way, that I'll be doing this kind of question, this kind of question, or I'll be solving a very, very toughest books. And what will happen, that there will be some stress, and due to that stress you will not able to achieve what you can do very easily. So let's solve this question. There is a thin circular disk of mass m having a radius. Let me draw one disk for you. There is a thin disk of mass m and radius is r. The horizontal plane about an axis passing through the center and the perpendicular to the plane of the angular velocity is omega. Okay, it's moving with an angular velocity omega. You know what? It's there is a relation between I1 omega 1, and if this is a disk, then its moment of inertia is mr square divided by 2, and omega is omega, right? This will be a relation. Now what is happening, this is the initial case we are having. This is the initial case. In the final scenario, there is some slightly change. What gets changed here? Basically, we are placing another disk of the same dimension. We are not changing the dimensions. The dimensions are same, but there is another disk, and there we are having radius r. You have to calculate that what is this angular velocity. Now you know what gets changed here. There is another disk which is being placed, but there is an addition of mass here of m by 2. So I could do one thing. The net mass here is m dash will now be m plus m by 2 to 3 by 2m. That is the mass, right? I hope that this thing is clear to you. So I could say that I2 omega 2 will be equals to m. This time my mass is 3 by 2m r square divided by 2, and omega 2 we have to find out. This is equation number 1, this is equation number 2. We have to compare this two values. Then you can do one thing using 1 and 2. Mr square by 2, mr square by 2 will get cut. Omega will be equals to 3 by 2 omega 2. So omega 2 will be equals to 2 by 3 omega. So our answer is 3. Right? Yes, it's more than sufficient. So you are working constantly for us. Thank you so much. And thank you, Praveen, for having such a beautiful word. Yeah, I didn't said anything when you gave the answer, but it's my duty to solve it for the other students because they will be watching it later on. So what happens is that this pdf you will get in our telegram group, and in that telegram group I gave the suggestions to my students that they can do one thing. If they do not have time and they do not have time to attend the complete lecture, they can do one thing. They can see the pdf, and after seeing the pdf they could see that sir have solved these many questions in this class, and try to solve those questions. If you are not able to solve, then come again and watch this class. Let's move to the another question. Here, this question: a block is simply released from the top of an inclined plane as shown in the figure above. The maximum compression in the spring when the block hits the spring is. Actually, this question is not from the rotational. This question is not from the rotational. You can do very simple. This is not a rotational question. Not a rotational question. But you can do very simply. Just see what is the potential energy at this point, and at this point you can get the potential energy accordingly mgh, right? This is 10, this is 30 degree. So you can get it 10 sine 30 degree. The height is 10 sine 30 degree, right? So you will get the potential energy, and at this point there will be a maximum potential energy. The maximum potential energy at this point will be equals to half k x square. So just by comparing you will get the answer. But this is not a rotational motion, so we are not solving it. This is your homework. I have given you the technique, or I have given you the way to solve it. I have a doubt. D option. Not go for that. Varun Sandesh, tell me what is your doubt. If you have doubt, you have to ask me, right? Then only I can help you. Okay, and this question is also this question is favorite question. I would say there is some mismatch. I think this question is also not from the rotational motion, but somebody has asked it. So according to this question, tell me what could be your answer. Tell me what could be your answer, because I have seen that many student commit a mistake here, and even I have seen that there are like, if you watch, if you see the solution of this question on online, you will get the incorrect answer, because JEE have provided the correct option. And do let me know that what is the answer here. Tell me, Varun Sandesh, tell me, what is your doubt? Tell me what is your doubt. The weight experienced by the person. There is a heavy bar. There is a heavy bar. The bar makes an angle theta with the horizontal. The weight experienced by the person will be W by 2. W by 2. Okay, this is very, very important. Very, very important. Two times I have seen this question. The same question was asked by NTA. Now, let's move. A string is wrapped around the rim of a wheel. So this question is from JEE Main 2024, 9th April shift 1. According to this question, a string is wrapped around the rim of a wheel. So there is a wheel of moment of inertia 0.4 kg meter square, and the radius of this is also provided. It's 10 centimeter. I'll consider this as 0.1 meter. And the wheel is free to rotate about its axis. Initially, the wheel is at rest. Omega naught is equal to 0. The string is now pulled by a force 40 Newton. The angular velocity of the wheel after 10 seconds will be what? Okay. So this question is very, very simple. You know what? Force is equals to I alpha, mass into acceleration. So torque is equals to I alpha, right? And torque is also equals to R cross F. So you can write this as RF I alpha. So using this, you could find out alpha, and once you get the alpha, you have the omega naught, you have the time as well, because time is also given to us as 10 second. You can easily get that what is the angular velocity omega. So try to solve this question. Everything is being provided to us. This is 0.1, this is 40 Newton. Alpha I is also provided 0.4. We can easily get the alpha. This is 4 divided by 0.4 is equals to alpha. So alpha is 10. So we have alpha as 10. So you could write this alpha as 10. And to get the omega, we have alpha t. So omega is equals to 100 radian per second. Okay. So can you tell me some strategy to succeed in physics? Yes, whenever you are solving the questions, do not go for the questions. You have to see what is the concept behind that question and what is the approach. I told you that you have to remember only few concepts. See, most of the students thinks that the JEE syllabus is very, very large. But I tell you that JEE syllabus is very small, very small. And see, in rotational motion, just we have to complete this eight topics. The ninth one is my technique, the technique which I am sharing now. right? The 8 parts we have to complete, and we have like I have explained you each and everything in this class only. So you must know, and there are some techniques which you could use, that for the moment of inertia, it's not important that you will be remembering each and every object's moment of inertia. You just have to think that which kind of question have been asked by NTA. So I can concise it that only these 4 shapes you must know, and if you know these shapes, you will be able to solve questions which comes in your JEE exam. So this is what we are doing it now, and I have taken every question which was asked in JEE 2024. I hope you are getting it. Is this thing clear, my dear? Is this thing clear, my dear? Please do let me know. Sir, in photon, it's Yash J. Sir, in photon theory, photon will collide with electron na, and collision between photons and electrons perfectly elastic na. Photon theory. I'll discuss that when I'll discuss the dual nature of matter. Let's me move. Okay, this question was very, very important. And I think that April attempt question, this, okay. Now April attempt will be done. After that, it's January attempt. So for the January attempts, I will suggest that you will do it on your own. This is the last question. This question is very tricky. JEE Main 2024, 9th April, shift 1. According to this question, a circular disc reaches from top to bottom of an inclined plane of length L. When it slips down the plane, it takes t second. It takes t second. When it rolls down the plane, it takes alpha by 2, 1 by 2 t seconds. Where alpha is, let's assume there is an inclined plane. There is a radius r. So according to this question, a circular disc reaches from top to bottom for inclined plane of length L. This length is given to you. Try to solve. It's a disk. So if this is when it slips down, if this disk slips, then it takes time t1, and if disk rolls, it takes alpha by 2 root alpha by 2 t seconds. Now you have to find out that what is the alpha. See, what is the basic difference between the rolling and the slipping? When it slips, we just need to take. When it slips, we just need to take that how much distance it's covering. It will cover, if this is theta, I'm taking that this is inclined at an angle theta. This is L sine theta, right? So I know that for slipping, case 1, when it's slipping. So for case 1, when it's slipping, how we could do that? Time is what? Under root (2s by a net), right? So I could write it as under root 2l divided by g sine theta. So I'll be having this equation. Are you all getting? And when it's rolling, then what will be my acceleration? When it's rolling, then what is my acceleration? My acceleration will be case 2, rolling. Now someone was saying that rolling is not in the syllabus. Someone was saying that rolling is not in the syllabus of JEE and NEET. And I was astonished that JEE was asking again and again the questions from rolling. So you must be well acquainted with the rolling, isn't it? Arey, tell me, isn't it? That is required. You cannot ignore it, right? You cannot ignore the concept. So here, A dash is equals to g sine theta 1 plus k square by r square, and k is equals to r by root 2. A dash 1 plus 3 by 2 . This is what I will get. 2g sine theta divided by 3. This is my A dash. Right? Is this thing clear? Now, for getting the time, this thing is clear, I hope. For getting the time in the next case, what you need to do is you have to use the same equation. It tells you that the time is 2s divided by the effective g what we are having. So for the next time, I would be saying that 2s, so 2l divided by effective is 2g by 3 sine theta. Okay, so this will get cuts. I have to compare it, so I will not cut it. Will be equals to 2l multiply by 3 sine theta. I'll do one thing. I'll keep it separate. Because I have to compare it with this thing, right? Because I have to compare it with this thing. So I'll be getting this T2 will be equals to root 3 by 2 and T. So if you compare this, you will get that alpha here according to the question is 3. Are you getting? Are you getting? Rathai Kamal? Yash JEE. I hope that this thing is clear. Now we have completed the January April attempt JEE 2024. I'm keeping all the questions from JEE Main 2024 January attempt. You have to attempt this question on your own. So this is your homework. This is again your homework, and you will see that these are similar type of questions what we have already been discussed. This is also your homework. This is also your homework. This is also your homework. This is your homework. This is your homework. Okay, and this is your homework. So this PDF you will get from our Telegram group. To get this PDF, you have to join our Telegram group. There is one task which you need to do. Join our Telegram, and do recommend this to your friend as well, because on this Telegram you will find a PDF, or you will get a link there. In that link I have provided each and every lectures link directly, so you do not need to search it on the internet, or you do not need to scroll it down from your YouTube feed to get my lectures. There you will get each and every lecture in a perfect sequence. You will get the notes which I'm writing it here. You will get the DPPs for your practice, because these lectures, only attending these one shot videos will not going to help you. But if you are watching these videos, and after watching this video, if you are solving the numericals which is required as per the pattern, or I would say as per the level of questions which I have put according to the JEE Main 2025 expected questions, so you will get very good marks. Okay, so this is what I have to discuss in this lecture. If you have any doubt regarding any question, you have to comment below, and do let me know that which is the next chapter which you want me to take. I have already planned it, that I'll be taking the simple harmonic motion, and after simple harmonic motion I'll be starting with the modern physics. So it's going to be a very good journey with all of you guys. So do not miss those lectures, and if you haven't subscribed our channel, please do subscribe and do share with your friends. So we will meet again in our next class. Till then, bye bye.